Congratulations, Rod. And our final awardee is Jim White, who was chosen as the winner of the Sensors and Controls campaign. Jim is a senior energy conservation engineer at Chelan County Public Utility District in Washington State. James designs and implements energy efficiency and renewable energy programs for public utilities. He was the originator and designer of the Chelan County PUD's award-winning Sustainable Natural Alternative Power Program for making solar and small wind cost-effective in an area with some of the cheapest electric power rates in the nation. Jim's idea is an improved design for variable air volume mixing boxes, combining temperature and CO2 sensors to control minimum airflow settings of individual VAV boxes, as Jim proposes would yield significant energy savings. Jim.
Thank you very much. I'll keep it really short because we're at the end of time. The idea here is utilizing carbon dioxide sensors to control the heating and cooling systems inside space. This space right now is most likely controlled by what's called a variable air volume system. So there's a big unit on the roof. It supplies cold air down to the individual boxes. They're called variable air volume boxes. And there's a big unit on the roof. Its purpose in life is to supply cold air and fresh air to the space. It pumps air down to the buildings, down to individual zones. Every little square you see on here is a thermostat. Back of the wall, there's a thermostat there, there's a thermostat there, there's a thermostat there. And each one of those controls modulates the space temperature by reducing the outside air. So this is a 3D printed box that Oak Ridge National Lab printed out for me. It has a damper on this end, so cold air comes in and it reduces the amount outside air if space is getting colder and colder and colder, but it stops because it doesn't want to go too low because then you wouldn't have enough fresh air for ventilation in the space. So the idea is just simply to take and put next to the thermostat a carbon dioxide sensor, which will allow the to go from a minimum position. So the problem with the current systems and the way they're so inefficient is that the cold air comes in, shuts down, let's say 30%, blows in cold air. They say that's too cold. So if it's too cold, what can you do? You can always add heat. So there's a heater on each of these units that reheats this cold, precious air that you paid so much to get and reheats it back up to the temperature to maintain your space temperature. And the idea is simply, instead of setting that box at a minimum condition of 30% or 50% in the case of our headquarters building in Chelan County, allow it to go down to enough to still satisfy the space requirements. We're at 780 parts per million currently in this space. And you can pick off the table, you can see we're currently providing about 30 cubic feet per minute for the occupants in this space. So this is why do this? I do the commercial industrial energy efficiency for our electric utility. We have very poor performance. We've got a 40% reduction. This was changing it from, changing the CO2 from 50% down to about 30%. So what are some of the next steps? CO2 is commonly, demand control ventilation is not a new concept. It's usually applied at the main air handler. And this concept is just to simply apply it to the box level, down to the individual thermostat level. The price of these units has come down $250 per unit, mass produced. So the idea is, let's see more of this, make it a standard. Thank you very much.